You're watching PowerNation. Today on Engine Power, we get into the nuts and bolts of engine building and check out a high horsepower diesel drag car.
Then we put a stout hot rod LS through its paces on the dyno with a new standalone EFI system.
Hey everyone, welcome to Engine Power. Now, I know what you're thinking. Usually when you see us, we have a pile of parts and an engine to assemble. But this time, we have a complete engine that is ready to rock and we're gonna get it on the dyno. But there is a very good reason for it. My man Frankie is also out chasing parts. So to dyno this, I recruited some help. And I would like to introduce you to the newest member of the PowerNation team, Michael O'Gwin. Now, Michael and I have similar backgrounds. We chewed a lot of the same dirt in the NHRA. Him with Doug Herbert and Antron Brown in the top fuel pits, and me with Greg Anderson and Jason Line in Pro Stock. But adding to that, we are both instructors at High Performance Engine School. So, Michael, thanks for joining us.
Man, Pat, I'm super excited to be a part of the PowerNation family. And today we're going to get rolling on this ATK high performance engine. ATK offers engines from all extremes, mild to wild, to fit your application. So if you need a new engine, whether it's a stock replacement or something custom for your application, contact ATK out of Grand Prairie, Texas. They were actually put together in 2007 and been doing business for a while now. This particular one is a Gen 3 5.3 liter engine where the ATK has gone through all the machining processes and gotten this up to spec for us. A tip for you, the next time you're shopping for your next LS project, there are different generations that require different parts. The Generation 3 LS engine has the camshaft position sensor located at the rear of the block. The Gen 4 blocks move the cam sensor to the front on the timing cover. Another thing to look for is the reluctor wheel of the crankshaft. The black crankshaft position sensor is used with the 24-tooth reluctor wheel, and the gray sensor is used for the 58-tooth. The cylinder heads on this engine is what really sets it apart for our custom application. These are from AFR. They are fully CNC ported on the chambers and also the ports. And then it leads us to the intake system where we have next level performance.
Yeah, this is the FiTech Ultimate Rebel LS kit. This system gives you everything that you need to complete it in your vehicle. And it starts off with this manifold. This is a very low profile, fits nicely. They make these for both Cathedral and rectangle port. It comes with their 102mm throttle body, all the lines, connections, rails, and injectors, which are a 55 pound/hour injector, so you can run gasoline, E85, or whatever you want. Also, it has their own set of coils, which have a really neat feature that have a blue LED indicator light to show that they are functioning. FiTech has made it very easy to add electronic fuel injection that is user adjustable to the LS platform. They include a custom wiring harness for easy plug-and-play connection, and they also include the necessary sensors required, like a 3-bar map sensor just in case you want to run up to 30 pounds of boost, an inlet air temp sensor, a throttle position sensor, and 2 oxygen sensors. This kit is self-learning, and it can provide sequential fuel and spark control with individual cylinder trim.
And the brains of this FiTech system is their Ultimate LS ECU, which is programmed with their handheld controller.
Well, enough talk. Let's get this thing in dyno, see what it makes.
Let's go.
Up next, we talk about one of the keys to success in engine building using premium fasteners designed for the application.
We build a ton of engines here at PowerNation, from daily drivers all the way up to full race engines. And the one thing in common that they all need is quality fasteners. From the balancer bolt to the flywheel bolts and everywhere in between, each engine needs high quality fasteners. That's why we choose ARP. Automotive racing products was born when the founder realized the need for high quality studs and fasteners. ARP manufactures, machines, and tests all their products in their Southern California facility. From OEM replacement components to exotic hardware found in Formula One, NASCAR, and NHRA, ARP's reputation is nothing but the best in the industry.
Here at Engine Power, we mainly deal with the engine fastener side of ARP, but they literally make fasteners for anything that you're working on. As far as materials go, we mainly use 8740 in stainless. 8740 chromoly is used in things like the oil pump drives, the balancer bolts, things that hold on the crank and cam and whatnot. Also, we use a lot of their 6 and 12-point stainless fasteners for things like intake manifolds, valve covers, water pumps, headers, and things like that. They come in packages like this specifically for the component, or you get an accessory bolt kit that covers your exact application. And another thing, ARP goes the extra mile and creates tools to help you assemble your engine better and more accurately. Things like the installers for the head studs. Also, for checking rod bolt stretch, which is very important. That's the most stressed fastener in the engine. They make some very accurate gauging for checking that both in analog like this or digital. And this is nice because it has an output. If you're logging it on a computer, it has an output where you can log it into a build sheet if you're using it. Also, if you're filing rings and you have to get your ring in the top of the bore square, they make specific ring squaring tools so you can get your ring in there, get it square, and measure your ring gap accurately. Also, they have tapered ring compressors in very specific bores, so no matter what bore you're working on, you can get the right size one so your rings go in nice and easy. Over here, something you may or may not have seen before, these go on rod bolts. If you have conventional engines with rod bolts, no matter if it's 5/16, 3/8, or even 7/16, these are guides that you can screw onto the bolt, not only protecting the threads of the rod bolt, but also protecting the crank journal when the piston assembly slides in. Another thing we love about ARP is if you need a fastener for your particular application and they do not manufacture it, you can get with their engineering and testing team and they will develop a fastener exactly for your application. And that goes for any sort of material, from conventional 8740 chromoly like they use in their head bolts, head studs, main bolts, and main studs, all the way up to something as exotic as Aramet or titanium, depending on what you're doing. For instance, Aramet has a tensile strength of over 260,000 PSI. Not sure what you'd use that for, but they can make you something that will work just for you.
So the next time you're in the market for high quality fasteners for your engine or the rest of the vehicle, make sure you hit up ARP.
Coming up, this extreme Cadillac comes off the track and into the shop to give us the lowdown on its diesel-powered Pro Mod engine.
One of our favorite things to have here in the shop is a cool race car. Let alone a race car, this one is a Cadillac race car, but this one is not what you think.
That's right, this Cadillac is actually diesel powered, and its owner, Jared Ring, we actually have him in the studio today to talk to us about this car. So Jared, real quick, give us the story of the car, how you got it, what class you run it in, the whole lowdown.
So this car is a 2016 ACS. This car was actually Larry Larson's MPK car. He built this car back in 19. They did very well with the Cadillac. Larry had never sold a car in the past of his own race car, and PRI last year, we took him an engine, let him mount it in there for us, get it all kind of ready. We took it home and we were racing it by April of this year.
So real quick, tell us what the engine combination is, tell us how fast the car goes, and if you have a guess, how much power is it making?
So this thing has a Freedom Racing's engine, Billet Cummins-based diesel in it. It runs S&S high pressure fuel system, an S&S controlled Motec system for all of our data logging, as well as all the things that run the car. Makes anywhere from 2,800 to 32, 3,400, depending on what we've got set up in it at the time. One of the things that we have brought on board this year with this car especially is Hot Shot Secrets, and we're running all their lubricants and everything. Get a lot of help from those guys and what we should be running and problems that we're having, trying to work through them together, talking with our engine builders, our transmission builders, our torque converter guys, just everything. Those guys have supported us a lot, brought us a long ways over the last little bit.
Like support on something like this is not your normal engine. We're doing something with a diesel here, obviously, that is something that is way out of the box, right? So how does that translate into Hot Shots helping you on the R&D side? Because you're really needing something very, very special to do this. How is that instrumental in what you're doing?
This block that's in this car is a new block in the last year or so that's been released by Freedom. And when we saw differences in what we were doing between the engines, bearing wear is one, cylinder wear was another one, different things, we changed some weights, we did some different things, got that stuff moving forward. They've helped us a lot, work through all that kind of stuff and showed us the different things. We've tried different things, done different things with it, and made progress for sure.
That's excellent. I mean, those relationships are invaluable, especially for you guys when you're pushing something like this to the extreme. So obviously they're known for the diesel world, but this is an extreme form of diesel. So how did you get started with them? How did they become a part of your program?
They have helped our stuff a lot. I mean, they do a lot for us. They provide oils and have helped us with stuff with our tow trucks, with our our toter packages, all of our things that have made our stuff better coming through it. We're really glad that we finally opened up to them.
Now, you're running with the big dogs, like you're saying, and you're running it with a diesel, right? And that's, you're trying to get it down to a time where you're running competitively with, doesn't matter what's on the track. So how fast has this car been?
This car's fastest pass at the current time has been 4:03 at 186.
Wow.
That's pretty quick.
So we're still working on lining a bunch of things out on this car.
Okay.
But it is doing well so far.
I think now we should get a look at the power plant.
I'd love to. Yeah, I mean, the car is beautiful, and it's, all stock body panels and stuff, but really, for us, that's the treat right there. So if we can, let's take this front end off and take a look.
Yeah, for sure.
Woo, that is a good looking piece of billet. But you gave us some relative specs. Tell us more about the engine. Anything you can really that you're willing to share.
This is a Fleece Performance Engineering block with Windberg crank in it. We're running D&J rods and diamond pistons. So this engine shifts about 6,300, has a Waggler head on it, conventional style 24 valve head. S&S provides all the fuel system for this thing. It has twin 14mm pumps and a set of very large ordnance injectors in it. They did all the wiring on this car as well. That's included in their Motec program. We provide air to this thing through the Hartz 102 charger. So the Hartz charger makes anywhere from 90 to 120 PSI. We regulate all the boost through Turbo Smart wastegates. It is all piped by Cody at 1X Precision Performance, build this beautiful header and stuff over here. That exhaust there is Larry Larson's original exhaust port for when he was running a big single on this thing. It also has about 7 kits of Nitrous Express on it, including Nitrous Express water injection, Peterson oil system, all hot shots everywhere. What makes this thing go.
What do you see for wear when you're doing, tear down or service intervals on the engine? What do you guys see when you're doing your inspections?
The hot shots does great. We haven't had any bearing problems. We haven't had any scorching problems in the pistons. No issues like that.
All right, well, Jared, we really appreciate you bringing this in. We love seeing cool stuff like this, and this is definitely one of the cooler ones.
Yeah, man, thanks very much. Good luck, and we hope to see you on the track somewhere.
Yeah, thank you guys. Thanks for having us out.
Up next, we get our LS running on the dyno and see what this high-performance crate engine can do.
All right, we're gonna get programmed in here. We're gonna go basically 3,000 to 68, 6,900.
FiTech does a really good job labeling everything, so depending on your experience level, it's easy to hook up and get running.
That's the key right here, because I'm gonna fire this thing up.
Boom.
Nice job. All right.
There we go.
This engine, it's a crate engine. Everything's been put together right and all that. It's been run before. So tell me about timing. What do you have right now for timing in it?
We're a little over 24 degrees.
Okay. It's a street engine with a full accessory drive running on pump gas.
Right.
So we always err to the side of caution. All right. Let's make a rip on her. Right through
all the way.
7,000. All right, right on the hill. Okay, very good. 446.2 horsepower, 377 pound-feet. Now, 77 at 5,500 and 446, pretty high, 6,800. That's that manifold. It's low profile, but it's got a little short runner in it.
Right.
So it's going to want to trend up a little bit. But man, for having a full accessory drive and exhaust manifolds on it, and a low profile manifold, that's pretty good.
It's pretty good there.
Fuel looks good, so we're gonna start sneaking some timing in it.
Right.
So go ahead and stick 2 degrees in it, and we'll go there.
All right.
Here we go. I am very impressed. Okay, a little bit more. Okay, 450.5 horse at 6,800.
Yep.
Okay, that's good. 379.7 for torque, and that is.
That was 2 more than last time.
And see what's nice, like on torque, it's printing at 78, 79, 79, 79. Nice flat.
Carries.
It's up high.
Yeah.
And again, that is a characteristic, well, that torque peak being right there, that's a characteristic of that short runner.
Yeah, that pushes that RPM. You're looking for the higher RPM there with
Right.
the short runners.
So everything looks good. All right, well, you want to put 2 more degrees in it and see if it levels off?
So the data that we're looking at, spark plugs, all that looks good.
All right, well, go jammy 2 more degrees in her, and we'll see if that torque levels off.
Sounds good.
All right, so 2 more. So we're at 28.3. All right,
Let it rip.
I'm not letting it rip.
Okay, that's fine.
You let it rip. Now if it blows up, it's your fault.
Oh, that's fine. Okay. Ready?
Yeah, just yeah.
All right, there you go. We got 380 on the torque. It's definitely leveled out. It's got a happy spot. I don't know. I mean, that's pretty smooth, and not for onesies and twosies it right now on the tune-up.
Right.
It looks good. It looks healthy, and that's what more could you ask for a street application?
I
there.
know. This thing, when the torque level out with that big a swing, because you took another 2 degrees at it, and torque literally leveled off. So
Right.
on pump gas stuff, you're not going to get anything more out of that. And again, we don't put everything on the razor's edge because you're one bad tank of gas away from wounding something if you're hammering on it.
Right. Yeah. If you're on the edge right there.
So O2s are tracking great. Oil pressure is going up. Very nice. Hey, we did it. Everything ran great. You did a great job. This is your first time dynoing something.
Super fun.
It's funny guys. Frankie's going to be mad that he's missing all the fun, and you get to dyno some stuff. But that's what happens. Hey, we got to go chase parts. So he'll be back momentarily. But you'll get to give him the good news of how this thing done. So job well done, man.
Thanks.
All right, Pat and Mike wrapped up that dyno session with that great LS. And I was out getting these TrickFlow 230 small block Chevy heads for an upcoming project. And this gives us a great opportunity to go over today's Summit Racing tech tip, and that is CCing combustion chambers for cylinder heads. We do this on every engine so we can get an accurate compression ratio calculation. And it's really important, but it's also something you can easily do at home. The first thing we're gonna do is install the spark plug. It's very important that you use the correct spark plug for the application and for the cylinder heads. It's also important that the valves are properly sealed, so you either want to use the correct spring package that you'll be using for the engine, or if you don't have those yet, you can use a set of test springs and a little bit of engine assembly grease on the valve seats to make sure they are properly sealed. We'll also use engine assembly grease to seal up around the chamber, so we'll use a very small amount and just a dab of our finger and go around. We're not trying to get any inside the combustion chamber. We just want a nice ridge around the outside so it'll seal up. Sometimes I'll take my finger and run it along the edge just to keep it all kind of away from it. But once we have enough there and it's gonna seal up, we'll grab our acrylic plate here. And sometimes if the valve protrudes from the deck surface, you have to put a little notch in it just so it can actually sit flat on there. And when we're putting this on, we want our fill hole to be the highest point in the combustion chamber so all the air can escape. So gently get this on there. You can see as it seals up, just want to make sure it's going to be nice and sealed all the way around. None of the fluid can escape. If you do have a good bit on there, you don't want to push it so hard where it ends up inside the combustion chamber, taking up too much volume. So that should be good like that. That should seal up. All right, now that our chamber is set up, we can get our 100cc burette set up. Now we're gonna fill this with 70% isopropyl alcohol. This generally works the best, or you can use 90%. I've seen some people use like antifreeze, which works fine, but it's a little bit harder to get all the bubbles out. So we're actually going to overfill this a little bit above the 0cc mark. All right, then we will raise it up. We do this so that when we purge the air out of the burette, we can just catch any excess fluid that comes out. So we'll put that there. And then what we'll do is we'll crack our valve, and you'll watch the air escape out of the bottom, have it fill with fluid, and then we can set our level at the 0. So we're gonna put the bottom of the meniscus on the 0 line. So now with this set up, we'll take it over to our cylinder head. Definitely always hold on to the Billet itself so you don't drop it, because if you drop it and hit something hard, it's probably gonna crack and then it will be useless. So we're just gonna get this set up right over our fill hole. All right, and then we can actually fill the combustion chamber. And we generally will fill it a little faster than what you would think. So we find sometimes that helps push all the air bubbles out. But you definitely don't want to spill any. You want any of the fluid that comes out of the Billet to go into the chamber to get an accurate measurement. So we'll just kind of let it fill up there. Make sure all the air bubbles are coming out with the fluid as it rises. Okay, then we can take our Billet and move it away from our chamber and look at our measurement here. So this is a direct reading, and it looks like 68.5. It's easier to see in front of something, but that is the measurement for this chamber. Now you can do all the chambers and check each one individually, but this is something you can easily do at home and hopefully will help you on your next engine build.